Let's take a look at the last part of this question now, a very good one. It says, hence or otherwise determine the values of x for which the inverse graph is greater than the original graph. So remember your g of x graph, this was the 2x plus 5 graph. The g minus 1 graph that we've just worked out the equation for is equal to, if we look at our previous answer, it's equal to a half x minus 5 over 2. So what they're saying over here is, where will this graph be above this graph? So if you look at this original graph, we could do a little sketch if you want, and you could see this happening. This graph over here, when we found the 2 points where it cuts the axis, this cuts the axis at 5, and it went through at minus 5 over 2. So your original graph was a graph that looked something like this, okay? And then this graph, which is the inverse, means the x and the y just change around. So this has a y-intercept of 5. This one would have an x-intercept of 5. This passes through at minus 5 over 2 on the x-axis. It would go through minus 5 over 2 on the y-axis. So what happens is this other graph is going to, at some point, let's just try and draw it. Here's your inverse graph. So there's your inverse graph. That's your g minus 1 graph. That's your g. So the question is saying, at what point will this graph, the g graph, be above the f graph? So if you look at this now again on the original, which might be a little bit clearer, what they're saying is this. I've resketched it on the original as well, and we can see what's going on here. So here's your original graph. That's your g graph. You can see it goes through 5 and through minus 5 over 2. Then your inverse graph, it goes through 5 on the x-axis and minus 5 over 2 on the y. And you'll notice that eventually these two graphs intersect. And this point where they intersect is very important because everywhere to the left of this point of intersection, this is your dotted graph, this is your g minus 1 graph. And your g minus 1 graph is above, you can see, this is above your other graph. Everywhere else, this graph's above this graph. So here's the original graph, and wherever you go this way, you can see this graph is above this graph. But from the intersection onwards to the left, it swaps around. So your g graph is above, the g minus 1 graph is above your g graph. So we need this point of intersection. So what we need to say is we've got the two graphs, y equals 2x plus 5. The other one was y equals a half x, and I think it was plus 5 over 2. These two graphs must be intersected. So let's go and intersect these two graphs and see what that point of intersection is. Just want to double check what our answer was for that graph. It was a half x plus 5 over 2, if I'm not mistaken, minus 5 over 2. So here's your other graph. Y equals 2x plus 5 must be intersected with a half x minus 5 over 2. So we can make them equal. 2x plus 5 equals a half of x minus 5 over 2. Take this over, so that's 2x minus a half x, that's 1.5x equals minus 5 over 2 minus 5. So it's 1.5x equals minus, that's minus 7.5. Divide by 1.5, x equals minus 5. So what we've determined is at the point where the two graphs intersect, let's go back to this question over here, the two graphs are intersecting at x value of minus 5. So this value here where they intersect is minus 5. Everywhere from minus 5 to the left, we're going to have a situation where the g minus 1 graph is above the g graph. So the answer is simply that x must be less than minus 5. And should it be equal to minus 5? Well, there it's equal. So anywhere less than minus 5 would be the correct answer. Okay, quite a very nice question there. You have to find the point of intersection and then just recognize that at the intersection point, the g minus 1 graph is now above the g graph. Let's take a look at the next one.